Sound check. I'll get everything set up. Look. Check sound. Sound check. Sound check. Yep, sound's on. Okay, so we'll just be waiting for Twit to catch up and then we'll get this show on the road. It has played catch up now, so we'll get started in a second. Right, let's get cracking. Just share working. Play the old song and dance again. There we go. Right, let's get it going. We're almost there, we're almost at the end. We only got 3 chapters left, and we're halfway through one already anyway. Okie doke. So we're back on Learning Go, and it's constraints. I'm going to put what potion on because I'm going to be on at least right now, so might as well. So constraints. And this is in the chapter for generics as well. So sometimes you need your generic function to know something about the type that operates on. The example we used in the first exercise didn't need to know anything about the types in the slice, so we used the built-in any constraint, like that. So square brackets between the function name and the arguments. Constraints are just interfaces that allow us to write generics that only operate within the constraints of a given interface type. And the example above, the any constraint, is the same as an empty interface because it means the type in question can be anything, creating a custom constraint. So let's take a look at the example of a concat function. It takes a slice of values and concatenates the values into a string. This should work with the any type that can represent itself as a string, even if it's not a string under the hood. For example, a user struct can have a dot string that returns a string with the user's name and age. Should work with any type that can represent itself as a string, even if it's not string under the hood. For example, a user struct can have a dot string that returns a string with the user's name and age. This is where the dot string method is used. That's why we need more specific constraint instead of the any constraint. Yeah, makes sense. Type string interface. Yeah, okay. So assignment. We have different kinds of line items that we charge our customers credit cards for. Line items can be things like subscriptions or one-time payments for email usage. Complete the charge for line item function. Check if the user has a balance with enough funds to be able to pay for the cost of the new item. So check if the user has it. Complete charge line item. Okay, so check if the user has a balance with enough funds to be able to pay for the cost of the new item. Balance. New item. T is line item. So I guess if balance is greater than, is it new item dot get cost. If they don't return insufficient funds, error, and 0 values for the other return values. If they do have enough funds, so if that return so it's going to be just an empty array. Look, 64 0 and new, what is it, like errors dot, is it errors dot new? How do you do it again? So errors. Errors package. Okay, errors dot new. And what does it say? Insufficient funds. Insufficient funds. Okay. Yeah, if they do have enough funds, add the line item to the user's history by appending new item to the slice of old items. And equals append old items, new item. Calculate the user's new balance by subtracting the cost of the new item from their balance. This is your second return value. So we return old items 0.0 and then nil. So it was calculate the user's new balance by subtracting. So I guess new balance equals new balance is new item dot get cost. Is that right? Syntax error, expected, unexpected comma, unexpected type on 11. Whoops. Zero. Slice. Oops. So it doesn't like this part. What's the zero value of the thing? Expected comma. Go return zero value. Zero value slice. How do I do that? Nil. Alright, okay. Whoops. got the colon. Okay, I think I got it. Yeah, easy peasy. So interface type lists. So when generics were released, a new way of writing interfaces was also released at the same time. We can now simply list a bunch of types to get a new interface / constraint. So ordered is a type constraint that matches any ordered type. An ordered type is one that supports less than or equal to, greater than equal to. Why might you create an interface using a type list? Why might you make an interface using a type list? You know exactly which type to satisfy your interface. It's too much trouble to define the methods required for your interface. Why might you create an interface using a type list? Check which type satisfy your interface. That one? No? Explain this bit. This one I'm not quite too sure of. So you know exactly which types satisfy your interface. So, glad to you, young coder. Type list interfaces constraints explicitly enumerate the concrete types that satisfy them, ints or string or float64, because the set is listed. You know exactly which types match, no methods are involved. This is useful for generic code that needs operators like less than and plus, or type controls over allowed types. It's not about avoiding method definitions, it's about precisely constraining which types are permitted. Would you like a quick example showing how this affects generic functions type parameter? Sure. So go only allow these ordered types and their aliases for T. So ordered interface works only for T in ordered, so plus and less than are valid. Okay, T, A and B are both T, okay. Min, yeah, okay. Int, okay. Compile error, uint not in ordered. Comment 64 not listed. Uint not in ordered, not listed. Complex 64 not listed. Because ordered lists int, float 64 and string, only those and their type aliases are accepted. The compile enforces this at compile time, so you know exactly which types satisfy the interface. No, I kind of get it. So parametric constraints. Your interface definitions, which can later be used as constraints, can accept type parameters as well. So your interface definitions, which can later be used as constraints, can accept type parameters as well. So type store P product interface sell P. The store interface represents a store that sells products. It takes a type parameter P that represents the type of products the store sells. Okay. Type product interface price and name. Type book struct. So function B book price. Okay, this is all connected to that name. Yep. Type toy struct price and name. The bookstore struct represents a store that sells books. Sells adds a book to the bookstore's inventory. So bookstore, sell, book sold. Yep. The toy store struct represents a store that sells toys. Sells adds a toy to the toy store's inventory. Sell products takes a store and a slice of products and sells each product one by one. So sell products. Products. P, okay. Okay. And then takes a store. P. Yep. Products, an array of products. Okay. Okay. Function. So bookstore. Was this bookstore? Blah blah blah. So by passing in book as a type parameter, we can use the sell books function. Oh, can't see the rest of it. Oh, there we go. We can use sell products function to sell books in a bookstore. Sell products. Book is the product type and a reference to the bookstore, and the array of books is these. Okay, we can then do the same for toys. Print toys sold. Okay. Assignment. The chief architect at Textio has decided she wants to implement billing with generics. Specifically, she wants us to create a new biller interface. A biller is an interface that can be used to charge a customer, and it can also report its name. There are two kinds of billers. User biller, cheaper, and org biller, more expensive. A customer is either a user or an org. A user will be billed with a user biller, and an org with an org biller. Create the new biller interface. It should have two methods. Charge. So charge. Good news is charge and name. Name. Turns the bill. The good news is the architect already wrote the user biller and org biller types. For us that fulfill this new biller interface. Use the definitions of those types and their methods to figure out how to write biller interface definition. Is it just that? Or do I have to have the customer passed as the thing? 59. In call to test biller, type org biller of test biller does not match biller C. Can I infer C? CV. Oh, 1 minute. Right, important job done. Okay, so I misunderstood the syntax of the interface thing really then. So it's saying interface should fulfill, it should have a charge method that takes a customer, which is C, returns a bill, and name that returns a string. Happy days. Naming generic types. So let's look at this simple example again. So split any slice like that. Remember, t is just a variable name. We could have named the type parameter anything. T happens to be fairly common convention for a type variable. However, type variable, similar to how I is a convention for index variables in loops. This is just as valid. Any type the name of a type parameter must be t. Can be anything, but t is a common convention. Can and should be whatever you want. Okay, enums, and then we got the quiz. So lack of enums. So my least favorite part of Go. Glad you asked. It's Go's lack of enums, some types, tagged unions, etc. compared to other statically typed languages like Rust, TypeScript, or Camel. Go's type system isn't powerful. It's more similar to C's type system than it is to Rust's. It's more concerned with simplicity than it is with expressiveness. So error handling. In Rust, like Go, errors are just values. In Go, we write something like this. Get user, yeah. Do something with the user. In Rust, we can do something like this. So let user result equals get user. Let user equals match user result. Okay, user that, error user that. I actually quite like that syntax, quite nice. In Rust, the getUser function returns a result type, a type that is either OK or an error. The compiler forces the developer to handle the error case before they can continue with the happy path using the user data. In Go, the developer can choose to happily ignore the error value if they choose, and the user data, even if it's invalid, probably nil or an empty struct. The support of enums in Rust makes it easy to write bug-free code. Assignment. So where's the enum come into that then? Support for enums in Rust makes it easy to write bug-free code. So assignment. A lazy Go programmer wrote the handle email bounce function. Just because the compiler doesn't force us to check errors doesn't mean we shouldn't. So take a look at the update status and track methods in the user.go file. Handle their errors properly and use fnt.errorf function with the %w formatting verb to add useful context to the errors. If update status fails, return an error saying error uploading user status error. If track fails, return an error saying if tracking error is bounced, blah blah blah, where error is the error returned by the method. Okay, let's have a look. EM recipient user what was it? Update status. I guess error equals colon equals that. I guess if error is not equal to nil, then fnc dot error f So error updating user status and %w error. So error was that. So if error is not equal to nil, then fnt dot error f was that %w error. What does track do? Track ATOL bounces. No new variables on the left side of colon equals. Line 12. Track. Say track error. Update status error. I guess return. Okay. Easy enough. Just handle it. So type definitions. For all its faults, TypeScript does have a pretty incredible type system. Here's one of the things it can do that I often miss in Go. So a union, so email, SMS, and phone. The sending channel type that we can create is a union type. It can only be one of 3 strings that we've defined. That means when a developer calls send notification, they can't accidentally pass an invalid sending channel like Slack or even a misspelled email. The TypeScript compiler will catch that mistake at compile time. In Go, we don't have these nice things. We embrace the grug mentality. The closest thing we have to a union type is a type definition. Okay, const email sending channel equals that, and that. Ugh. Yeah, it's a little bit ugly, that. Sending channel, okay. It's a bit safer than using plain old string in Go, but it's not completely safe. Go will stop us from but it's not completely safe. Go will stop us from doing this. String is not sending channel. Type definition. A type definition creates a new distinct type with the same underlying type and operators as the given type and binds an identifier, the type name, to it. but it will not stop us from doing this. Slack is automatically implied as a sending channel. And it will also not stop us from doing this. So sending channel Slack, converted sending channel is equals to sending channel this, and then converted sending channel. Okay. The sending channel type is just a wrapper for string, and because we made some constants of that type, most developers will just use those constraints. We've made it easy to do the right thing. That said, Go still doesn't force us to do the right thing like TypeScript does. Assignment: use the following code to answer the questions. In which case will Go compiler raise an error? Check permission write, check permission user, check permission read, check permission admin. Perm string read write execute, read write admin user. Okay. Type definitions. Yeah, okay, I already said that. We'll check permission perm admin raise an error from the compiler. So check permission perm admin. Nope. Is that Jota or IOTA? IOTA, I think it is. IOTA, so Go has a language feature that when used with a type definition, and if you squint really hard, kind of looks like an enum, but it's not. It's called IOTA. The IOTA keyword is a special keyword in Go that creates a sequence of numbers. It starts at 0 and increments by 1 for each constant in the const block. So in the example above, email is 0, SMS is 1, and phone is 2. Go developers sometimes use IOTA to create a sequence of constants to represent a set of related values, much like you would with an enum in other languages. But remember, it's not an enum, it's just a sequence of numbers. Define email status type that uses IOTA syntax and represents the following states. So email status, like that. Email status, and it's going to be email bounced, email invalid, email delivered. So email bounced, email invalid, email delivered, and email opened. Okay, huzzah! Right, now we're on to the final quiz. So we could be done pretty early tonight, to be honest. We're on to the quiz. So, similar to the Zen of Python that we covered in the Learn Python course, the Go proverbs are a beautiful collection of wise words from Rob Pike, one of Go's creators. Don't communicate by sharing memory, share memory by communicating. Don't communicate by sharing memory, share memory by communicating. Concurrency is not parallelism. Channels orchestrate, mutexes serialize. Okay. The bigger the interface, the weaker the abstraction. Make the zero value useful. Interface says nothing. Go FMT style is no one's favorite, yet Go FMT is everyone's favorite. What? A little copying is better than a little dependency. Yeah, that's fair. Syscall must always be guarded with build tags. Cgo must always be guarded with build tags. Cgo is not Go. With the unsafe package, there are no guarantees. Clear is better than clever. Reflection is never clear. Errors are values. Don't just check errors, handle them gracefully. Design the architecture, name the components, document the details. Documentation is for users. Don't panic. Watch Gopher Fest 2015 Go Proverbs with Rob Pike.
It's a nice little thing. Yeah, that one picture of the whole program. So if you space or whatever, who cares? Shut up. Go fun style.
Okay, I'm gonna have a watch of that. Let me put it on my watch list. Rob Pike. Go for Fest 2015. Go Proverbs with Rob Pike. Yep. Okay, I'll definitely watch that. So, clear is better than clever. Which is better, including a little dependency or copying a little code? Copying a little code. Documentation should primarily be written for users of your code. Errors are special, something to be caught, just values, exceptions. Just values. Claim 10,000 XP. Yes, please. Oh, nice. Oh, I almost went up 2 levels. Great course once again. There were a few places where I felt the instructions were a little unclear, but otherwise spot on. Boots the bear coming in clutch again, but otherwise spot on. This has been a great overview. This has been a great introduction to Go from someone who hasn't used much statically typed and compiled languages before. Can't recommend it highly enough. I'll skip on the review thing. Let's open the chest. Yay! Got some baked salmon, another one. Yay! I've got loads of things to open. I've got a big chest thing there. More baked salmon. Hey, I see a stone. Another one. Hey. What's next? Another one. Yeah, not bad. Gems and baked salmon. 5 gems and baked salmon. Oh, a nice fancy chest again. Whoa. Gems and 2 baked salmons. Gems and an XP potion. Achievement unlocked. Milestone Grandmaster. Complete 960 exercises. So 1.3% of students have earned this achievement. Now in the top half. Okay. Another LinkedIn post for me. the simplicity and error handling as values. Sorry, course, and I built some muscle memory for the language in the process. Am I a gopher? Am I a gopher now? Another emotion language and post that. Yeah. So this is Go, programming language. What else is it? I guess it's what do you call it? Compiled. Current programming. The Boot.dev. Boom. Bingo. There we go. Howdy, hey. So let's get back to the dashboard. So that means we are donezo for today. And we're making good progress. It's getting towards the end of October now. I think we're getting through things pretty decently. I think, to be honest, the aim for the end of the year will be to get through these. I think doing these more advanced ones are probably not going to happen this year. But if I can get to the end of this stuff, like up to 23, that could be really good. Some of these are a lot shorter as well, so it might not take so long. Like learn HTTP clients in Go. That's going to be starting next week. So don't know if that will take, it's less lessons, but maybe it'll take longer. Don't know. Maybe we smash it out in a week. Be interesting to see what the Pokedex one in Go is, and the SQL. I need a good refresher on SQL, to be honest. Blog generator. And oh, did that move? Oh wait, HTTP clients, HTTP servers. Okay. Learn file servers and CDNs with S3 and CloudFront. Yeah. So we're getting there. I mean, it's not, maybe we're not as far as I wanted to be at this point in the year, but just gotta power through. So we go on courses, backend TypeScript path. Ooh. Already kind of done that. We'll come back to that. That was added in before. So learn HTTP clients and Go will be the next thing. Am I an Archmage yet? I have to get to level 100. How do I know if when I get to level 100 though? How do I know how far away I am from it? I'm not really bothered about these ones. I'm never going to do the streak because I'm just not on it. It's just while I'm doing the things. What's this? Shop. Let's have a look at the shop because I don't really use it, to be honest. I have loads of gems and I don't really use them at all. XP multiply. I'm going to have to start remembering to use these. Keep armor handy, protect your sharpshooters free from breaking. Feed Boots baked salmon to ask for help without losing XP. See a stone, consume a sea stone to view a solution without XP penalty. Frozen flame will protect your streak for 4 days when you need a break. I think I'll use some gems because I don't think there's anything else to use it on. So I was going to buy some potions. Armor. Yeah, I'll probably get some of these. Baked salmon, that's fine for now. I don't really want to use that. 1, 2, 3, 4, 5, 6. That'll do. There you go, all spent. What the boss thing is. Pythagoras. Event has ended. Check back soon. Pasta feed on the 6th. Alchemy is collected. Wow. It's on the blog. Talk at leaderboard. Boom, I'm up there. Top league learners. You're in position 3 of 25 league members. Global leaders daily learners. Top community members. Recent arch majors. Wow, there's a lot of users, Lane. Blimey. But yeah, I guess starting next week we'll be looking at this one. Learn HTTP client headers, clients with Go. Also available in Python and TypeScript. I want to do it in Go. Learn how to use HTTP and Golang to interact with APIs and the web. Make requests, handle responses, and use JSON API. So we're going to be like, why HTTP? Learn about HTTP and how the powers of the majority of web communication. JSON, learn the most popular data formatting notations of the programming world. DNS, learn about domain names and how they map human readable names to physical servers. URIs, understand URIs and URLs at a deeper level. Headers, practice adding custom headers to HTTP requests and learn about authorization. Methods, paths, HTTPS, errors, and curl. Use a curl and JQ to make HTTP requests from the command line. Looks nice. Yep. Looks good. So, that's it for tonight. We're just going to call it there. End it early. So that was the end of that one. Really enjoyed it. I'm looking forward to coming back next week and smashing out everything in Learn HTTP clients in Go. I think we'll probably get through it in 1 week, and then it means like the next week we build the Pokédex. After that, SQL, and we get through these because we are slowly running out of months to do it. I mean, to be honest, I might even have so it renews on the 9th of January, my thing, so I want to try and get through it all before I need to pay for it again. I'm not going to be able to get through the deeper learning parts, but that's fine. I think that's probably going to be a step too far. Might even have some full streaming days because I've got some time to take off, so I might even use it for that and power through. But anyway, thanks for coming down. Thanks for watching. That last part was like a really easy, just straightforward thing. But yeah, I'm looking forward to getting started with the HTTP clients in Go from next week. So thanks for coming down. See you next week. Have a good night. I'll just say in English.